Question number 7. This question is of trigonometry. Part first of this question is, by first expanding cos theta plus sin theta whole square, find the three solutions of the equation cos theta plus sin theta whole square is equal to 1 in the interval 0 to pi. This is the interval given in radian. We have to find three solutions of this equation. So first we will expand this by using the identity. Cos theta plus sin theta whole square, using identity cos theta plus sin theta whole square, identity a plus b whole square, a square plus b square plus 2ab. So this becomes cos square theta plus sin square theta plus 2 sin theta cos theta. We know that this is given that cos theta plus sin theta whole square is equal to 1. This is given. So we can put in place of cos theta plus sin theta whole square, this is 1. So we can put 1. But on the right hand side also there is cos square plus sin square, that is equal to 1. This is identity. So this is equal to 1 plus 2 sin theta cos theta. 1 minus 1, this becomes 0. So we can write as 2 sin theta cos theta is equal to 1 minus 1. 2 sin theta cos theta is equal to 1, dividing is equal to 0. Dividing each side by 2, this becomes sin theta cos theta is equal to 0. So cos theta, sin theta into cos theta is right side पे 0 है, so we can separately put sin theta is equal to 0 or cos theta is equal to 0. Sin theta is equal to 0 or cos theta is equal to 0. Sin theta is equal to 0, where we get theta is equal to 0 and pi, because sin 0 is 0 and sin pi is also 0. So we get two solutions from here, and from this cos theta is equal to 0, cos pi by 2 is 0. So we can say that theta is equal to cos inverse 0, that is pi by 2. So we have three solutions, 0, pi and pi by 2. There are three solutions of this equation, 0, pi by 2 and pi. This is the answer. These three solutions are the solutions of this equation, cos theta plus sin theta whole square is equal to 0. इस equation के ये तीन solutions हैं. Now part second of this question is, hence verify that the only solutions of the equation cos theta plus sin theta is equal to 1 for this interval 0 to pi are 0 and pi by 2. इस इक्वेशन के इस इंटरवल में सिर्फ दो सॉल्यूशन है, 0 एंड पाई बाय 2. ये हमने वेरीफाई करना है. तो फर्स्ट वी राइट द इक्वेशन cos थीटा प्लस sin थीटा इज इक्वल टू 1. Now these are the solutions we have to verify. 0 and pi by 2 are the solutions. First we put theta is equal to 0 in this equation. We get cos 0 plus sine 0, that is equal to sine cos 0, that is 1, sine 0 is 0, so this becomes 1 plus 0, that is 1. So this shows that theta is equal to 0 is the solution of this equation. Now the other solution is pi by 2. Now put theta is equal to pi by 2 in the same equation. We get cos pi by 2 plus sine pi by 2. Cos pi by 2 cos 90, that this is 0, and sine pi by 2, that is 1. So we get 0 plus 1, that is equal to 1. This shows that these two solutions, theta is equal to 0 and theta is equal to pi by 2, satisfy this equation, because on the right hand side from is equal to 1 by both these angles. This is verified. Verified that the solution of this equation in this interval are 0 and pi by 2. Next part of this question is part B. Prove the identity sin theta over cos theta plus sin theta plus 1 minus cos theta over cos theta minus sin theta is equal to identical equal to cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. We have to prove this identity. So first of all, we will take the left hand side. Left hand side is left hand side of this is sin theta over cos theta plus sin theta plus 1 minus cos theta over cos theta minus sin theta. So clearly these two fractions we convert it into single fraction by adding. So we use here LCM process, taking the LCM. LCM is both these factors are LCM, cos theta plus sin theta into cos theta minus sin theta. So dividing the LCM by this factor cos theta plus sin theta, this will be cancelled. Only we have this cos theta minus sin theta. We will multiply it by sin theta, so we get sin theta into cos theta minus sin theta. In the same way, now this will be cancelled by this. Dividing the LCM by this factor, we cancel this, or we have only cos theta plus sin theta multiplied by 1 minus cos theta. So 1 minus cos theta into cos theta plus sin theta. Now we will multiply this sin theta by this bracket, and these two brackets are there. Multiply कर देंगे इन दोनों को. We get sin theta cos theta minus sin square theta plus cos theta minus cos square theta plus sin theta minus sin theta cos theta divided by Now we will multiply the denominator. Here we will use the identity a plus b, a minus b, a square minus b square. So this denominator will become cos square theta minus sine square theta. This will be cancel out, plus minus opposite sign, due to opposite sign cancel out. So we get sin theta plus cos theta minus sine square minus cos square. Sin theta plus cos theta minus, we are taking common from these two terms, within bracket sin square theta plus cos square theta divided by cos square theta minus sin square theta. So sin square plus cos square is equal to 1. So we can write sin theta plus cos theta minus 1 over. We can write this cos square theta. We can convert this cos square theta into sin square theta. Cos square theta is 1 minus sin square theta. So in place of cos square theta, we can write 1 minus sin square theta, because we have to show this. In the denominator there is term of sine, so we can convert the sin square, cos square into sin square. So we can write this cos square 1 minus sin square minus sin square. So finally we get sin theta plus cos theta minus 1 over 1 minus 2 sin square theta, that is equal to right hand side. We have proved this identity. This is left hand side. We have proved it equal to right hand side. Cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. So next part C of this question is, using the results of part A and sub part 2 and part B, solve the equation. We will use the above parts, part A and sub part 2 and part B. Part B is this. This is part B, just we have proved, and part A sub part second is, these are two solutions. We will use these two parts to solve this equation in the interval 0 to pi. So clearly we have shown that this left hand side of the above part, this is equal to this right hand side. So in place of this, we can put its right hand side here. So in place of this, we can put its other form. This become cos theta plus sin theta. In place of this left hand side, we are putting this, just we have proved. So cos theta plus sin theta minus 1 over 1 minus 2 sin square theta is equal to 2 is equal to this, 2 cos theta plus sin theta minus 1. We have to solve this equation, or we have to find the angles in this in the given interval. So there are two possible ways. First, we can cancel out this cos theta plus sin theta minus 1 also is on the left hand side, also this is on the right hand side, this is same, so we can cancel out. We get 1 over 1 minus 2 sin square theta is equal to 2. So we can write it in this form: 1 minus 2 sin square theta is equal to 1 over 2. Rearranging, we get 2 sin square theta is equal to 1 over 2. From here, sin square theta is equal to 1 over 4. So we get, taking square root each side of this equation, we get two values of sin theta. Sin theta is equal to plus minus 1 over 2. This means that sin theta, either sin theta is equal to 1 over 2 or sin theta is equal to negative 1 over 2. So from here we can find the angles, taking inverse of 1 over 2. Theta is, we are finding theta, so theta will be, we are finding basic angle. From here, basic angle is theta is equal to sine inverse 1 over 2, that is pi by 6. Other angle will be by using this sketch ASTC: all positive, sine positive, tan positive, and cos positive. Since sine theta is positive, the angle will lie in this quadrant and in this quadrant. In first quadrant, we have find the angle pi by 6. No, in the second quadrant, angle will be pi minus pi by 6, because sine theta is positive in both these quadrants. In quadrant 1, first quadrant, we have found the angle pi by 6. In the second quadrant, angle will be pi minus pi by 6, that is 5 pi by 6. So other solution is pi minus pi by 6, that is uh, 5 pi by 6. So these are two solutions, pi by 6 and 5 pi by 6. And secondly, this is not applicable because sin theta is negative. Clearly sin theta is negative. Negative sin theta lie in the third quadrant and fourth quadrant, but interval is only from 0 to pi. So this is not applicable. So this is not applicable. So only the solutions are pi by 6 and 5 pi by 6. These are two solutions. But also, since in the part A, subpart second, it is uh, clearly cos theta plus sin theta is equal to 1. Cos theta plus sin theta is equal to 1. If we are taking 1 in the left hand side, this becomes sin cos theta plus sin theta minus 1 is equal to 0. So we can put cos theta plus sin theta minus 1 is equal to 0. From here, we can put cos theta plus sin theta is equal to 0. If we are putting cos theta plus sin theta is equal to 0, then this whole equation become This equation become, we are putting here uh, cos theta plus sin theta minus 1 is equal to 0. Here, when we are when we put this cos theta plus sin theta is equal to 0, then this become by cross multiplying this will be 0. This becomes 0 by cross multiplying it, because we are putting cos theta plus sin theta minus 1 is equal to 0. So only we get cos theta plus sin theta minus 1 is equal to 0. So from here we have already found the solution of this equation are in part A and subpart second. It is very clear we have already found these two solutions, 0 and pi by 2. So from this is same equation, so solutions are 0, because we have already found 0 and pi by 2. So total solutions of this part of this equation, total solutions are total solutions of this equation are 0, pi by 2, pi by 6 and 5 pi by 6. So finally we write here the total solutions: 0, pi by 6, pi by 2, 5 pi by 6. These are the solutions.